Assalamu alaikum, dear students. Today our topic is B and F block elements. Now, first we will take D block elements. Now, what are D block elements? The elements which are in between S block elements and P block elements are called, these are also called transition elements. These have the properties which are in between S block elements and P block elements, and they represent a change from most electropositive S block elements to least electropositive P block elements. They are called D block elements because their D subshells are incomplete and the last electron enters the D orbital of their outermost or penultimate means last but one shell. तो डी ब्लॉक एलिमेंट्स हम ऐसे डिफाइन कर सकते हैं कि डी ब्लॉक एलिमेंट्स वो एलिमेंट हैं जो एस ब्लॉक एलिमेंट जो पीरियोडिक टेबल के लेफ्ट में होते हैं एंड पी ब्लॉक एलिमेंट्स जो उसके राइट में होते हैं. These D block elements lie between the S block elements and the P block elements. Their properties are, they show a change from the most electropositive S block elements to the least electropositive P block elements. They are called D block elements because the last electron enters the D subshell of their outermost shell, or we can say it is the penultimate last but one shell in which the D electron enters. So we will first write the definition of D block elements. Elements which are in between S block elements and P block elements are called transition elements. These show the properties which are in between S block elements transition from S block elements to P block elements. These show the properties, these represent the properties which are in between S block elements and P block elements, i.e. from most electropositive S block elements to least electropositive P block elements. These are also called D block elements. They are called transition elements because they show transition, they show change from properties from the S block elements to the P block elements. These are called D block elements because they lost an electron enters D subshell or D orbital of penultimate or last but one shell. जैसे कि हम दिखाएंगे when we write, इसके बाद हम इसका इलेक्ट्रॉनिक कन्फिगरेशन उठाएंगे तो उसमें हम देखेंगे कि how the electron enters the d orbital of their penultimate shell. So this was the definition of the d block elements. The d block elements are classified into 4 series which are called the transition series. These are classified into 4 series. Called transition series. The first transition series, that is also called first 3D transition series. Because these represent the filling of the electrons in the 3D orbitals in their outermost shell. So these are called, this is the first or 3D transition series, and the elements are from scandium 21 to zinc, that is atomic number 30, and the second transition series is from ytterbium 39 to cadmium 48. The third transition series, this is called, second transition series, second or (4D) transition series. It is from terbium 39 to cadmium 48 atomic number. Elements from terbium to cadmium. And the third transition series, or we can say 5D transition series, is from lanthanum to mercury 57 to 80. And then we have fourth transition series, which is also called 3D, 4D, 5D, 6D. Fourth 6D transition series. And these comprise of the elements from actinium to copernicium, that is 112. Now we will take these series one by one and write their electronic configuration. The first series, which is also called the 3D transition series, because these elements of this group corresponding their electronic configuration correspond to the filling of the electrons in the 3D subshell. So this is called 3D transition series, or the first transition series. Second transition series involves the filling of the 4D orbitals from terbium to cadmium from atomic number 39 to 48, and the third transition series, which involves the filling of the electrons in the 5D subshells, and these include the elements from lithium to mercury. Although from lithium we have lanthanide series, and we have then from hafnium 72 to mercury, and then we have the elements actinium, and we have actinide series, then we have the thorium from 104 elements from 104 to 112. These included the actinium. These are the elements that represent, that constitute, that involve the forming of the elements of this group and corresponding the filling of the 6D orbitals. Now, electronic configuration, the most important thing in these, how we can understand and how we can write the electronic configuration of these elements. We will take one by one the first, the 3-4 series. The first series that includes scandium to zirconium, we will write it as electronic configuration. Electronic configuration. The general outer shell electronic configuration is n-1, d1 to 10, and ns0 to 2. This is their general outer shell electronic configuration, or their general electronic configuration. This is the last shell. N is the number of the shell, n-1. This means the last but one shell, which involves the filling of the electrons in the d orbitals from 1 to 10, because we can fill up 10 electrons in the d subshell, and we have n as 0 to 2. Now we will take first that is 3D transition series. These we will write the elements, their atomic number and then the electronic configuration. The first transition series, they include the elements like scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And these are the elements. The atomic number is 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. We will first write the electronic configuration, full electronic configuration of the scandium, then we will write only the outer electronic configuration of the rest of the elements. Scandium, its atomic number is 21, that means 1s2, 2s2, 2p6, 3s2, this is also 3d, 3s2, 3p6, 3d1, 4s2, 2, 4, 10, 12, 18, 19, 20, 21. From this to this, we can write it is 18 helium, it is argon, which has the atomic number of 18, then it is 3d14s2. So the electronic configuration of the scandium is argon 3d1 4s2. So if we write only the outer shell electronic configuration, this is 3d1 4s2. Similarly, if we have to write the electronic configuration of titanium, which has only one electron more than the scandium, it will be, yes, it will be, तो आर्गन 18 तक आ गया, 19, 21, अब एक हमें बढ़ाना है, that means 3d2 4s2. This is titanium. Similarly, again we have one electron more than the titanium in the vanadium, that is 3d3 4s2, and in chromium it is 3d, instead of 4 we will write 3d5 and 4s1. जैसे कि इसमें 3 and 2 5 फिलअप करने हैं, इसमें 6, तो 5 and 1 6. अब क्यों instead of it should have been 3d4 It should have been 3d4 4s2, but instead of that it is 3d5 4s1. I will explain it. And again it is in the manganese, it is 3d5 4s2, 516 527. इसमें 8 फिलअप करने हैं. That is an error. It will be 3d6 4s2 and cobalt 3d7 4s2, nickel it is 3d8 4s2, copper it is 3d, it should have been 3d9, but instead it is 3d10 4s1, and in the zinc it is 3d10 4s2. So in the copper and chromium, we have the electronic configuration. These are called exceptional electronic configurations. Here it is because why the exceptional electronic configuration is in case of the chromium and copper, which is different from the rest of the elements. The trend is different from rest of the elements. It is because the half-pillared orbitals or the completely filled orbitals gain more stability, or the orbitals gain, atoms gain more stability by having the half-filled configuration or completely filled configuration. Now you see, अगर हम क्रोमियम लेते इसमें 3d6 4s2 आता, instead we write 3d5 4s1. 3d5 में d5 is exactly half-filled, so is s. In s we have 2 electrons, लेकिन हम यहाँ एक बात कहें, that means it is exactly half-filled. The half-filled configuration, exactly half-filled configuration, or completely filled configuration, the atoms gain more stability by such type of the configurations than the incompletely filled orbitals. So, in case of the chromium, we have d sublevels. In case of the chromium, it is exactly half-filled, and in case of the copper, it is that d sublevel is completely filled, so these gain more stability and prefer this electronic configuration. Now, regarding the rest, the trend is the same. जैसे कि हमने यहाँ से ही we have to fill the electrons and the lost electron introduce the d orbit. Now we have the second transition series 4d. In the 4d transition series, we have elements like ytterbium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, and their atomic number starts from 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. and we write their electronic configuration. This is atomic number, element, electronic configuration. If we take terbium, these series of the transition series of the elements, they involve the filling of 4d orbitals. अगर terbium का electronic configuration लिखेंगे, it is terbium 3d39, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d1, 5s2. We see the electronic configuration. 2, 4, 10, 12, 18, 28, 30, 36, 37, 39. So this is 36 यहाँ तक. तो 36 helium, neon, argon, krypton, helium 2, neon, argon 18, helium 2, 10, 18, krypton 36. Then we have 4d1, 5s2. Now similarly, we have to write the electronic configuration of the rest of the elements. Now we will write only the outer electronic configuration. तो पहले krypton, that is a low base, इसके बाद 4d1, 5s2. So it is for terbium, it is 4d1, 5s2. That is 39. Now in the zirconium we have one electron more than terbium, that is we have to add one electron, that is 4d2, 5s2. Now niobium we have 4d3, but instead of 3 we have 4d4, 5s1. Molybdenum 4d5, 5s1. Technetium 4d6, 5s1. Ruthenium 4d7, 5s1. 4d8, 5s1. And here in PD we have 4d10, 5s0. Again in silver we have 4d10, 5s1, and here again 4d10, 5s2. So you see the changes in the electronic configuration in these elements, that is the 4d transition series or the second transition series. It is terbium. Again I will write the name, I will read the name: terbium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. And terbium, I have written the complete electronic configuration, and the outer electronic configuration comes 4d1, 5s2. That is krypton 4d1, 5s2. Then we have zirconium, one electron more than terbium, that is 4d2, एक इलेक्ट्रॉन बढ़ाएंगे 4d2 5s2, चार को अब एक ऐड करना है तो यहाँ 5 होना चाहिए, 6, 7, 8, 9 सिमिलरली। तो जब एक बढ़ा दिया it enters the 4d, तो 4d यहाँ पर 1 था तो 4d2 बन गया 5s2। now in niobium, molybdenum, technetium or terphorium or rhodium, palladium as well as silver, we have the electronic configurations। क्या होता है यहाँ पर, instead of it should have been 4d3 5s2, 4d4 5s2, 4d5 5s2, 4d6 5s2, 4d7 5s2, 4d9 5s2, 4d8 5s2, sorry 4d9 5s2, 4d10 5s2। लेकिन instead of these, instead of 4d3 5s2 we have 4d4 5s1, instead of 4d4 5s2 we have 4d5 5s2, instead of 4d5 5s2 we have 4d6 5s2, instead of 4d6 5s2 we have 4d7 5s1, instead of 4d7 5s1 5s2 we have 4d8 5s1, instead of 4d8 5s2 we have 4d10 5s0, instead of 4d9 5s2 we have 4d10 5s1. This is because of the electron and the nuclear electron interactions, because of the shielding effect of the d electrons, and the orbitals are very close to each other. So due to the interaction between the electron and due to the interaction between the electron and nuclear electron interaction, we have this type of electronic configuration in the elements of the Saturn transition series. Now I will write the third transition series, which involve the filling of 3d, 4d, 5d orbitals. And we have the elements from lanthanum, the hafnium, and then mercury. We have elements that 57, then it is 72, 73, 74, hafnium, then tantalum, tungsten, ruthenium, osmium, iridium, palladium, gold, mercury, palladium, gold and mercury. In the third transition series, we have the elements like lanthanum, And after the lanthanum, we have lanthanide series that comprise of the 14 elements. That means their atomic number comes from 58 to 71. 14 elements, they are called lanthanides. And from lanthanum, we have hafnium, tantalum, it is tungsten, rhenium, osmium, iridium, platinum, gold and mercury. And their electronic configuration is, that is, यहाँ पर 4d1 5s2, we have 5d1 6s2. I will write the electronic configuration of the lanthanum, that is 57, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 5d1, 6s2. 2, 4, 10, 12, 18, 28, 30, 36, 40, 50, 2, 4, 10, 12, 18, 28, 30, 36, 46, 48, 48 and 6 हो गए 54, 55, 56, 57. That is lanthanum. So we have the outer electronic configuration, that is 5d1 6s2, 5d1 6s2. Now hafnium, it is 5d2 6s2. Tantalum 5d3 6s2, 5d4 6s2, 5d5 6s2, 5d6 6s2, 5d7 6s2. It is 5d9 5d8 6s2. It is 5d9 6s1, 5d10 6s1, 5d10 6s2. So we have, in case of the platinum, in case of the gold, lanthanum, it is 5d1 6s2. तो एक इलेक्ट्रॉन, इसके बाद यहाँ पर 4f electrons come while filling the, by writing the electronic configuration. So we have 5d2 6s2. तो 14 जो एलिमेंट्स आते हैं, इसमें 4f14 इलेक्ट्रॉन्स फिलअप होते हैं. तो टेंटालम एक इलेक्ट्रॉन इससे ज्यादा 5d2, ये 5d3 है 6s2, 5d4 6s2, 5d5 6s2. एक इलेक्ट्रॉन डी में जाता है 5d6 6s2, 5d7 6s2, 5d, here instead of 5d8 6s2 we have 5d9 6s1 and we have 5d10 6s1. So these two show the deviation. These are the exceptional electronic configurations than rest of the elements because of the electron or electron nuclear interactions. These electronic configuration of the ore of platinum is different from rest of the elements, and the gold, it has the completely filled d orbital and exactly half filled, which increases the stability. So it has 5d10 6s1 and 5d10 6s2. Similarly, we can show the electronic configuration of the 4 transition series that involve the elements like actinium 89 and Rutherfordium 102, because from 89, from 90 to 101, 100, we have elements 104, it is 104, sorry, 102, we have the 103, we have 14 elements from 90 to 103, we have 14 elements which are called actinides. So from actinium 89, we have Rutherfordium 104, and the last element is copernicium. Its atomic number is 112, and is involving the filling of the 6d electrons. So the outer shell electron configuration is 6, 5d, it is 6d1, 7s2, से start होता है and it ends at 6d10, 7s2. So this is all about the electronic configuration of the d block elements, which are classified into 4 transition series. Thank you.